The cosine rule. Let's say you were asked to work out the third side of this triangle here. You would probably know that you can either label this side using the vertices capital B, C, and call it BC, or we can use small a since it's opposite corner or vertex A. And likewise over here, I could call this one small b, and down here, this one lowercase c. And I can say, you might write for your first line on here, that means from Pythagoras, a squared equals b squared plus c squared. Looks like a nice straightforward Pythagoras calculation. Even if you did not write that line, you would certainly write this line because this line shows you know what you're doing and gives you marks in an exam. A squared equals 15 squared plus 17 squared. Either you would know or reach for your calculator. 225 plus 289. That's a squared. So put these together. A squared is 514. Of course, you've not disengaged your brain, so you know that that side could not possibly be 514. Common sense would remind you that you have to square root your 514. And when you've done your square root, you would get your 22.7 rounded off answer, and you say, give me the full marks. Thank you very much. That was a nice, easy question. And unfortunately, you would get nothing because you were wrong. The thing about a Pythagoras question, the fundamental truth is Pythagoras works providing we have a right-angled triangle, and nothing on this diagram says that this is a right-angled triangle. In fact, if you look closely, you might realize this angle looks a little bit less than 90 degrees. What would we do if we said this angle was 85 degrees? Well, we're not lost on our Pythagoras work that we've done, but there has to be some kind of adjustment to say, if this is 85 degrees and not 90, my answer must be a little bit less than the root 514, my 22.7 it looked like I was getting over here. There has to be an adjustment, and here's how it works. We have our 15 squared and 17 squared, and the adjustment says take away 2 times the first number times the second number and multiply the whole thing by the cosine of this angle, the angle opposite the side that we're wanting. The angle in between the sides that we know. So I'm just going to squish 85 degrees in there. So I have my 225 still and my 289, but take away, well, 2 15s are 30, 3 17s 51, 510, I multiply these numbers together, cos 85 degrees. At this point, frequently people will say 225 plus 289, take away 510, get my answer, and multiply by cos 85. No, no, no. That's the most common mistake on this kind of question. Because you know full well that multiplying is far more powerful than add and subtract. So yes, we'll put our 225 and 289 together, but then with our trusty calculator, we will say, okay, 510 times cos 85, just simply type it in, times cosine 85 equals, and there's my answer. Now at this point, although it says 44.449, I'm not going to round off. We only round off at the very end is the best practice for maths. So I'm going to say take away 44.44 and then just put ... blah, 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 if you like, to say there's a whole lot more numbers here. It removes the need to round off here, and also it removes any chance of a rounding off error here affecting my final answer. So I'll keep this answer on my calculator. I'm going to do 514, take this away. I'm not cancelling it. Right? You should know how this works, but if not, 514, take away, and I'll use the answer button because that will use the last answer that was on my screen. And when I hit equals, there we go. We've got our nice answer here, 469.55. And again, I'm not rounding off yet, so I'll just put dot, dot, dot. This is perfectly acceptable to the exam board. So A equals, and I'm looking for an answer a bit less than the 22.7 I thought the first time. So again, I won't cancel this. There's no point in doing that and then just typing in a rounded off version again. I will just say square root my answer, the number that was on the screen, equals, and there we go. And now I can take this and round off and say, there we are, 21.67, or indeed just one decimal place more than here, 21.7, which is also accepted there. So 21.67 or 21.7. Do round off in the end, but only at the end. Don't forget your units, and the question's done. So what happened there? We said it's like Pythagoras, a squared is b squared plus c squared. It's the two sides I have, but it's take away 2 times the first number, b, the second number, which is c, and the cosine, I would use a capital here, of the angle that corresponds to the side that's opposite the side that I'm trying to find. So cos A here. And that is called the cosine rule. And the great thing about the cosine rule is it works for any triangle at all, whether right-angled or not. So in your notes, and I would strongly suggest that you take notes if you don't already, your beginning of your notes would just be simply to say, cosine rule says in any triangle at all, any triangle ABC, and this is given to you as a formula in the Nat5 exam, a squared is b squared plus c squared. So a small a here squared, even when it's nothing like a right angle, is equal to b squared, opposite b, and c squared. It doesn't matter which way around they are really, but b squared and c squared. Take away 2 times the same letters again, b and c, the same figures, same numbers, cos, and the angle that's between the two sides that we know, and opposite the side that we're trying to find. That, I would suggest, starts off your notes. Then write down your first example, which would be this one here. And at this point, you might want to try 2 or 3 yourself, just to check you've got the hang of them. One other thing that often comes in to confuse people slightly, people say, well, this is very well taking away adjustment, but what if the angle in between here is not less than 90, but more than 90? In other words, if we had a question something like this one, for example number 2. What do we do here? Because this time our side is obviously going to be more than it would be if it was than a Pythagoras calculation on a right angle triangle. Calculate QR. I can call it QR, or I can call it small p, since it's joining vertex Q to vertex R. And I likewise could call this 8 centimeter side small q, and this 6 centimeter side small r. Or, because the question says QR, I can stick with the QR. It's entirely up to you. All right. I'm going to put QR just because it's the same form as the question. But again, as I say, you could put small p, p squared equals for the side. Well, I'm going to do the same steps as I did before. My 8 squared and my 6 squared. Take away 2 times the first side I know and the second side I know. Cosine, and the angle in between, 112 degrees. I've got to take away here, but I know I want this side to be longer. Trust the maths. Another great thing about the cosine rule, it always works. So, plug in the numbers. 8 squared, obviously 64, plus my 36. 2 times 8 times 6, 8 6 is 48, 96, cos 112 degrees. Again, we'll make sure we do the multiply before subtracting from this, which will be our 100 here. Again, I'll just put in my QR squared. 100. Take away. And now when I reach for my calculator, on here, when I do 96 times cosine 112, look at my answer, negative 35.96. Don't forget the minus sign there, because that means in here, it's take away negative. And again, I'm going to put 35.96 ... Don't need to worry about rounding off. I'm going to keep it precise by not rounding until the very end. As precise as possible. So again, on my calculator, I'm going to do 100, subtract, and use the answer button. And it automatically then has gone to something bigger than the 100, because take away negative, of course, it becomes an add. So my QR squared here becomes 135.96, blah, blah, blah. And my QR is the square root of that answer. Again, keeping the whole thing on the calculator. So since I've got this as my answer, I will just say root answer equals, and my QR, now I can round off, 11.66, or I'm just going to say 11.7 centimeters. Again, halfway through the calculation, I did not switch off my brain. I know this side must get bigger, so I know that when I get down to here, I cannot possibly get a smaller answer than my 100. So watch for the takeaway negative. It had to be something to make this side bigger. And then I get followed through to my 11.7 answer. And that's really as complicated as these questions can get. Cosine rule is just Pythagoras with an adjustment on the end. And you're given this format here on the formula sheet. But don't just try and learn a formula. The letters could be completely different. Just remember first side, second side, like Pythagoras. Take away 2 times first side, second side, and the cosine of the angle matching or corresponding, because it's opposite the side that we're looking for. Small a here, capital A here. And that's all there is to it.